Alright, now we're starting decay. Remember with decay that our A value has to be a certain number. Has to be between 0 and 1. So that's what a decay graph looks like. So in this case, let's have a look at our A value. You can see that it's 0.7. This shows me that it's going to be a decay graph, which means it's just going to go down over time. So examples of decay, such as cooling a cup of tea, radioactive decay, a drop in current when an electrical appliance is turned off. So those sorts of stuff is examples of decay. So let's have a look at this example. So the current I flowing through electric circuit in a fan, t milliseconds after it is switched off, is given by this function. Find the initial current in the circuit. Now initial, again, I'll explain it again, but it just means time equals 0. So that's just all we need to substitute in. So that means I of 0 is 320 times 0.7, and instead of t, you put a 0 in there. Alright, so if I do this calculation on a calculator or manually, I know that hopefully 0.7 to the power of 0 is 1, because anything to the power of 0 is 1. So it just becomes 320 milliamps. That's my answer. And let's do BI. So find the current after 4 milliseconds. So my t becomes 4. So I just substitute that one in. Alright, chuck it in your calculator. I get approximately 76.832 milliamps. Alright, I is the power of 10 for BII. So 320 times 0.7 to the power of 10. Chuck that in the calculator. You get 9.04 milliamps. Alright, now all I have to do, I've got all my information, I just got to graph it. So let's give that a go. Alright, I'll draw big because I've got enough space, why not? Alright, the things I need is my I, which is current, in milliamps. Alright, so there's some information. My T is in milliseconds. Now, let's see what values I need on my axes. My biggest value is 320. My smallest value is 9. So I just got to make sure I fit them in. So maybe let's go with 20. Let's see if 20 works. 20, 40, 60, 80, 100. It might work, it might not. We'll give it a go. Make sure you do it in your pencil. Oh, we might be pushing it. Yep, we're pushing it a bit. So I'm going to remove that. I'm going to do 30s. 30, 60, 90, 20, 50. So it's a bit of a trial and error. Right, that's enough. And then I just got to make sure my 1 to 10 fits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I just dot them. So when my time is 0, it's at 320, which is about here. When my time is 4, I'm about 76, which is approximately here. And when I'm at 10, I'm at about 9, which is about here. It's a very curvy graph, this one. So it looks something like this. Right, write the function. I is 320 times 0.7 to the power of t. Now do we see how it's a decaying graph? It's going down as time goes past. Then we know we're done.